Hello, my future engineers. I welcome you all to Rankplus JEE English, and today we are going to complete our alternating current. So, I hope that I'm audible and visible. Yes. So, do you know that what makes the difference between an average JEE aspirant and a topper? It's their mastery of concept that consistently appear in previous year questions. And guess what? And guess what? Alternating current is one of those topics that JEE loves to test. And why? Because it's not just about formula, it's about understanding the backbone of how the modern world runs. And today, I am facing the electricity issue. That's why I'm taking class this. Otherwise, I'll be taking on the smart board. Okay. So imagine this, that the entire power grid of India relies on this one concept. And today's we will not only understand AC but also crack some of the previous year questions that have stumped students over the years. So if you are a serious JEE aspirant, stay sharp because today's sessions could be the turning point. Let's dive into the world of alternating current with real questions from the exams. But before moving, I'm going to give you the information regarding our Telegram group. You have to, this is not moving, I think. Wait, is it moving? Not going. Right. Yes. So you have to join our Telegram group. And to join our Telegram group, the link is in the description. You can use that link. Otherwise, you can go in the description to check or in the live chat. Okay, there you will get the notes which I am taking the class. Also, you will be getting a PDF of all the formulas of physics there. Like you can easily revise those topics from those sheets. And also there is one information regarding the mentorship program, that if you want a personal one-to-one assistance from me, so you can book a session. This can be done from the Rankplus app. So you have to download the Rankplus app using the link given below, and you can book one-to-one session with me. The cost is only 499. If you are booking more than 10 sessions, the cost will be around 199 per session. So it's very cost effective and very effective to improve your score. The another thing is, this is a test series. Wait, I have to move myself so that this complete screen will be visible to you. I think that here it is fine. So there is a All India test series as well for the JEE students. You can join this test series at a price of 999, and this will be helpful for you to get a very good score in your April attempt. So do not miss this test series. The link is in the description. You can join. Okay. So whoever, shall we start? Shall we start? Yes. So here, the first question in front of you. I hope that it's visible. Yes. Now I think that it's fine. So question number 1 is in front of you. You have to solve this question. This question is based on that principle of resonant frequency and the peak current. If you want me to revise the concept of alternating current, you can tell me in the comment. Okay. Tell, I'm giving you 1 minute to solve this. Can I give you a timer from here? No, timer is not available. Let me choose some pen. I think blue color is fine. Yes. Shall I start? Hello, Nanny. Sir, tomorrow which chapter? Gaurav Tiwari, hello. Tomorrow you tell me that which chapter do you want me to take? Tomorrow, I think Very, very good, Gaurav. So by the end of today's sessions, I'm sure that you will be mastering your alternating current and you will feel confident while attending the questions related to the alternating currents. So let's record this alternating current chapter. So here's the question in front of you. You have to solve it. Here you have to find out the peak current and the resonant frequency of the circuit given here, right? So see, if I'm seeing the option here, there are two options which have the similar values, zero point 0.2 and zero point 0.2. Here I'm having the 2 ampere and 2 ampere. So can I use some shortcut trick to like removing two options? Can I do that? Tell me. Is there any way to get the correct answer without doing the actual calculations? Modern physics, you want me? Gaurav Tiwari, it's best to attend the lectures live, because when you are attending the lecture live, you won't be having any backlog, and during the exam time, it happens most of the time that if you miss one session, then it will be becoming your backlog. So it's better that you join live, and in live you will be solving these questions in the actual time, right? So modern physics, okay. Like tomorrow, I think that from morning we are conducting a mock session in which I'll be taking top 25 questions from the selected test series which we are conducting, and from other institute test series. So it will going to be a very helpful for all of you who wants to attend a new types of questions which are not previous year questions. So in the sessions you will be attending uh, those questions for the first time, right? But if you want me to take a different theoretical chapter where I will be teaching you the complete theory, I'll be taking the standard questions, plus I'll be also taking the previous year questions, then you can do the comment here below. Then I'll do that. Okay. Gaurav Tiwari? Yes. Now tell me how to solve this question. Tell me how to solve this question. What is the peak current and resonant frequency of the following circuit? Each and everything is given to you. Can you find out? Solve. Okay. I'm giving the time. Your chats are coming here. Shall I do one thing? I'll put your chat here. Shall I start solving or do you want more time? Remember one thing, the more you ask, the more you learn. Let's make the session a two-way current. Okay. Ask your doubts and watch the knowledge flow back to you. So every question has a spark of curiosity. Don't hesitate to ask question. We will turn that spark into your understanding. So I am starting the question. First of all, here we need to find out the current, and most of the time student faces issue in solving the alternating current because they do not know the correct approach. And first of all, I am here to clear your approach of solving the alternating current numericals. So the approach here is that you have to consider this as a normal circuit. So if it was a normal circuit, then if I need to calculate the current, approach is that in terms of think like a normal circuit and apply the basic principles which is required for the AC. Think like a normal circuit. This is particular approach which we will be using. Most of the time student tries to think differently, and the moment they try to think differently, they makes this question difficult, right? So normally if I need to find out the current is V by R. V by R normally for AC. For AC, when I am having different items here, different circuit elements, so it will become V by Z. Okay, now first of all, I need to calculate that what is the value of Z here, right? And in case of this is a particular case of RLC. Here I'm having the resistance which is having a value of 120 ohm. Inductor I'm having of 100 millihenry and capacitor I'm having of 100 microfarad. So Z is equals to R square plus XL minus of XC to the whole square. Okay. Now you can find out XL and XC separately. If you need to find out XL, it will be omega L. And from where you will get the omega? As we know that V is equals to V naught sine omega t. So from here, if you are comparing these things, you will get that omega is equals to 100. Are you getting my point? See, in this type of questions, just you have to get a very good observation. Plus, you need to know very small number of formulas. So 1 by root LC, Shweta Singh. Yes, it will be applicable, but it this formula is for the formula which you are saying, the formula which Shweta Singh is saying will be applicable to frequency is equals to 1 by 2 pi under root LC. Yes, this will be applicable. But here, if you see that there are two options in which you are getting 100, 100, and there are two options in which you are getting 50 and 50. So I think that you have to calculate both of the values like peak current and the resonant frequency, then only you can mark, right? This is what I'm telling you. Shweta Singh, is it okay? And Shweta Singh is a very popular name, like it's a namesake. You must have listened to the Aaj Tak news, and there also Shweta Singh anchor is there, right? So let's find out first XL. XL is equals to omega L, and omega I am saying that omega is equals to 100, and the value of L here is the value of L is 100 millihenry, 100 milli 10 to the power of minus 3. So it will become 10. It will become 10 ohm. Now XC, that will be 1 upon C omega. So in this case, you have to substitute 1 upon C. C is 100 microfarad 10 to the power of minus 6 omega. Omega is 100 10 to the power minus 2. It will goes up. It will become 100 ohm. Are you getting these values? 100 and 10 ohm. Are you getting? So ultimately, if you need to find out the Z here, it will come out to be 100 minus of okay. It will become 120 square plus 100 and 10 we are having, so it will be 90 square. and this you have to solve. If you solve this, what is the value you are getting? 120 square plus 90 square. So it will come out to be 150. Is coming 150. So Z will become 150. And the moment you get the value of Z, to get the value of I, is it, oh, it's not visible. I'll move to the next slide. Let me shift myself here. Right, so I need to calculate. So I is equals to V by Z, and the value of V here is 30. Right, it is 150. 3, 1, 5, 1 by 5. 1 by 5 is equals to 0.2 ampere. So current you are getting 0.2 ampere. So this can't be my answer. This can't be my answer. My answer will be either B option or the C option. Okay. Now I need to find out the frequency. To get the value of frequency, you need to substitute 2 pi, right? Frequency formula I have written on the top. Let me that thing. Frequency is 1 upon 2 pi under root LC. So for this, you can substitute 1 divided by 2 pi under root LC. So L is 100. So multiply this L 100. It will become 1, 2, 3, 4. 10 to the power of minus 3 and minus 6. It will become 10 to the power of minus 9. 1, 2, 3, 4. 3, 4 will be over. So it will become 10 to the power of 5. Right? So minus 5. And you have to calculate this. Can do one thing. So please bring next electricity and modern physics. I can do only one thing. See, you can do everything, but not, you can do anything, but not everything. Right? So it's better that I'll take, which one? Which one do you want me to take? Tell me. So it becomes 10 to the power of minus 5. I'll take this, if I'll use the calculator to solve this. 1 divided by 2 pi under root 1 into 10 to the power minus 5. So it will come out to be around 50 hertz. So my answer will become B option. So B option is my answer. Okay, I'm having a scientific calculator. This is very, very helpful. 991 ES. You will get this calculator allowed in your first year. Electricity. Gaurav Tiwari, which chapter do you want me to take? Let me move again. Do you want modern physics? I'll take modern physics. First, I think that it's better that I'll take combined 25 question or 30 question so that you will get a comprehensive practice. Otherwise, I can do one thing. Please do let me know whether you are targeting this January attempt or April attempt. Seriously, you have to tell me. Then only I can plan for the big. Like if we are targeting our April attempt, then it means that our basics must be very clear, right? So we will be targeting your basics first. I'll be covering the theories, the important questions. Then we will move towards the previous year. But if you are targeting this January attempt, then like we have to concise ourselves to the previous year questions, and particularly to the questions which are coming again and again, so that as a student you will like, if you are getting the similar type of questions in your exam, you will feeling you will feel very confident while solving those numericals, and it will not take more than I would say 10 to 20 seconds, right? In this question, tell me, January, you are targeting January. Okay, okay, fine. So here we are having another question. In a series LCR circuit, if we change the resistance only from lower to higher values, then what will be the effect? Tell me. Bandwidth. Okay. If you do not know about the bandwidth, I hope that you may know about the quality factor. Do you know about the quality factor? So in that quality factor graph, you are getting the minimum value, the minimum frequency, and the maximum frequency, right? There we got the maximum frequency and the minimum frequency. So basically, this range of minimum to the maximum, the range from minimum to the maximum frequency is known as bandwidth. Is known as bandwidth. Or we generally use this bandwidth term in the corporate as well. Like we all have 24 hours, right? In this 24 hours, 8 hours will be for our daily chores, daily works which you have to do. So we will be having 16 hours with us, right? In these 16 hours, you can do anything but not everything, right? You have to keep this thing in your mind, that you can do anything but not everything. So if you choose to do one thing, then you will be taking that time from your 24 hours, right? So if you are studying physics now, then it means that you won't be studying chemistry and maths at this time. So that is known as trade-off, or the you can say that everything will be having the second alternative. So you are not choosing that second alternative. You are choosing the best thing what you can do, right? So this is what I'm telling you. Is it clear? So in this question, because this question is from 2021, in that time we have the quality factor and the bandwidth, and you have to understand that here the bandwidth of resonant frequency will increase. That is the answer to this question. Next, now let's move towards the next question. Here we are having another question. It's from JEE 2021. The angular frequency of alternating current in a LCR circuit is 100 radian per second. The component connected are shown in the figure. Find the value of inductance of the coil and the capacity of a condenser. You have to calculate. Find the value of the inductance of the coil and the this L value you need to find out. And this capacitor you need to find out. Okay. Angular frequency is given to you as 100 radian per second. So omega is provided to you, and for this particular question, you need to find out that what is the value of this L and this C. So tell me how you're going to proceed this question. What will be the best method? With a Singh, Gaurav Tiwari, tell me how will you approach this question? How will you approach? First of all, what I can do is I can find out that what is the current flowing through the circuit, right? So can I calculate the current flowing through this resistance? Because voltage is provided to us and resistance is also there. So we know that current is equals to V by R. And if current is equals to V by R, we can do one thing, that I is equals to 15 divided by 60. 1 by 4. So it will be 0.25 ampere. Can you, right? Now, I hope that this thing is clear. Now these two, this resistance and this inductor, are connected in parallel, right? If these are connected in parallel, so I can say one thing, that both of them will be having the same voltage, right? So if this is at 20 volt, this must be at 20 volt. So if there is 20 volt, then what will be the value of current here? So I can say that it will be 20 V by R, right? So I can say that the current here will be 20 divided by 40, to 0.5 ampere. Okay. So zero point 0.5 ampere is flowing through this. Next, if okay, now let's move towards the next part. So here in this capacitor, I already know that current which is flowing through this is 0.25 ampere, and like if I'll consider the voltage, so that voltage will be I x c, right? V is equals to IR, so I can say that V is equals to IXC. Voltage is 10 here, current is 0.25, and XC we have to find out. So XC will be equals to 40, right? It will goes here. So XC will be 40 ohms. Are you getting? And what is the value of XC? XC is equals to 1 upon C omega. Omega is 100 because it's already been provided in the question that omega is 100 radian per second. So if you substitute that value, your capacitance will be omega into 40, so 1 upon 100 into 40, right? So this is what you will get. A very, very big value it will come. 1 by 4 is equals to 0.25, 123 milli coulomb. Shall I farad? Millifarad. Is it clear? So I can say that 0.2 millifarad will be my answer. But if I see the options, here in the options, I am not getting the values in millifarad. All the answers are in microfarad. So if I'll change this value to the microfarad, I can write this thing as 250 microfarad, right? So I can say that either B or C will be my answer. A wouldn't be my answer. D wouldn't be my answer. Now it's the turn for getting the value of L here. To get the value of L, what you can do is, tell me what you can do. Can you say one thing, that if 0.5 is 1 by 2, how much current will be flowing through this? I need to get that what is the value of current. The 0.25 ampere current is flowing from this direction, and I'm saying that this is zero point 0.5. Okay, so 0.5 is going in this direction, 0.5 is going in this direction. So can I say that my 0.25 will be moving from this if I'm taking this as the direction? Since this is alternating current chapter, so we do not have a particular directions, but still, if I'll going to apply the Kirchhoff's current law, so if I'm taking this direction as my main direction, like the value of current, So I can consider that the value of current in this will be 0.25, right? So if I'll apply a law here that V is equals to IXL, so V is equals to 20 here, I is equals to 0.25, and XL is equals to L omega. So it will become 25. So L is equals to 20 by 25. So 0.8. That means B is my answer. Are you all getting this answer? Athreya, brilliant villain. Wow, a great name you are having. Brilliant villain. I hope that this question is clear. Shall we move? Now, the next question in this, there are LCR circuit contains resistance of 110 ohm, a supply of 220 volt at 300 radian per second. Omega is provided to you. If only capacitance is removed from the circuit, current lags behind voltage by 45 degree. If on the other hand, only inductor is removed, then the current is leading by 45 degree with the applied voltage. So the RMS current flowing in the circuit will be, okay. Can you tell me that here, if we are removing the capacitor, the current lags behind 45 degree, and if we are removing the inductor, the current leads by 45 degree. It means that the circuit is in the resonance. Can you say that? The circuit is in the resonance. So this is a particular case of resonance. And in resonance, we know that XL is equals to XC, right? XL is equals to XC. And to find out the current, here we do not have to do anything, because we know that in case of resonance, current is equals to V by R. And the value of V here is 110, and the value of V, no, value of V is 220. Value of V is 220, and the value of resistance is 110. So you can substitute values here and you will get the current as 2 ampere. So it's a very easy question. It comes out in 2021. Let's move. Akhilesh, okay. Can I invest 4 days for physics only theory? Yes. Basically, it depends what is the output you want. Next question. This question comes in 2021. It won't be taking more than 10 seconds, I can say. I is equals to I1 sin omega t, I2 cos omega t. You have to find out the RMS current. And what is the RMS current here? Tell me. What is the RMS current here? 28 January for JEE Mains. Yes, you have time. You have the time. See, to get the RMS current, we know that RMS current is what? IRMS is equals to I naught by root 2, right? And if I'm having this type of a function, so can I say that I is equals to under root I1 square plus I2 square and a combined function of sine omega t plus phi, right? So if I'll compare, like this is my I naught here. If I'm comparing, my I naught will be I1 square plus I2 square, and you say that IRMS is equals to I naught by root 2. So you can substitute this. So I'm getting A as the answer. Are you all getting A as the answer? Shweta Singh? He? Why she? He or she? I hope that this question is clear to you. Now let's move to the next question. In the next question, here it's asking you that what happens to the inductive reactance. Inductive reactance is XL. and the current in a purely inductive circuit if the frequency is halved. So we know that XL is equals to L omega, and you can write this thing as L into 2 pi f. If the circuit consists of only inductance, then we can say that R Z is equals to R square plus XL square, right? And current is basically V by Z. So tell me, I have given you all the hints which I can give you. Tell me what will happen if we are decreasing the value of frequency. If we are decreasing the value of frequency, the value of XL will decrease, and if the value of XL will decrease, what will happen to the what will happen to the here? Oh, okay. It is saying that it's a purely inductive circuit. So for a pure inductive circuit, this resistance is 0. We can say that it is equals to XL. So I can say that here my current will be doubled, because if it is purely inductive circuit, so I can substitute the value here like V divided by L into 2 pi f. And if I'm decreasing the value of frequency by 2, ultimately my current will be increased by 2 times, right? Yes, Shweta Singh gave the correct answer. B option is the correct. Now let's move to the next question. Okay, now this question is also very, very easy. All the questions are easy related to the alternating current. If we know the basic concept and if we know the technique to break down the question into a simpler part, we will be able to ace these types of questions, right? Now, in this question, we have an AC source rated at 220 volt 50 hertz is connected to a resistor. The time taken by the current to change from maximum to the RMS value. So this question is very, very important. First of all, it is saying that basically you have to consider, like, I'm considering a sinusoidal curve here. So for a sinusoidal curve, the maximum value will be at this point, right? The maximum value will be at this point. And from here, I want to go to the RMS value, time taken by the current to change from its maximum to the RMS value. So how will you approach this type of question? And is connected to a resistor. Okay. Okay, fine. Then can I say, like, I can solve this question logically as well. So can you create a playlist by your videos? Yeah, I will do that. I think that playlist is already available. If you go on our channel and you will see the playlist out there, you will find physics by Manoj Sir playlist. Right, in that playlist you will be getting alternating current, physics, the mock paper you have, EMI, complete physics formula, ray optics, moving charges and magnetism, atoms, current, electricity, electrostatics, moving charges and magnetism. Again, okay, okay, that was the formula. Semiconductors you will get, then thermodynamics, simple harmonic motion, rotational motion, one shot. Oh, I have divided rotational motion into two parts. Yes, there was some electricity issue like today. Today also I am facing the electricity issue at my end. Then we have motion in a plane, gravitations, and one video is private. I do not know that why this video is private, but you can see that. So playlist is already available. Okay, Atriya. Okay, now fine. Shall we see this thing? So here I know that I need to get IRMS, that my IRMS is equals to I by root 2, right? IRMS is equals to I by root 2. And to get this value, I need to find out that what must be the time, right? I need to find out that what must be the time for this. It will be very easy if I'll take the cos graph, because in sine graph I need to consider that will it come on the left side or will it come to the right side. If I'll take a cos graph, then I think that easy to remember or easy to find out. Okay, so now we know that at time t is equals to 0, if I'm taking a cos omega t as my function, this is the sine omega t. If I'm solving this for the cos omega t, I can say that at t is equals to 0, my value will be I naught, right? So I can say that I is equals to I naught at t is equals to 0. And I want that at what time my I will become I naught by root 2. To get the value, see, if I'm considering that I is equals to I naught cos omega t, if I'm considering the cos function, then to get the value I naught by root 2, I have to substitute this cos omega 2 as, like, I have to substitute this omega t as pi by 4. Pi by 4 is 45-degree angle, right? So I need to substitute that value. So from here, I can get t is equals to pi by 4 omega, and omega is 2 pi f. So pi will cut, you will get 8f, and frequency is already given to you. Frequency is 50 hertz here, right? Frequency is already given to you. So time period, if you have to find out, pi will also, that's why I have to. So time is equals to 1 by 8f. So it will be 8 into 50, 400, 1 by 400, and okay, so you will be getting 0.25 or 2.5, 2.5 millisecond. 20, yes. 2.5 millisecond. So please do part for thermal physics. Atriya, I have to write down that what are the demands coming for all the chapters. Like in my mind now, I have that I have to take modern physics. I'll love to take modern physics chapter like atoms, nuclei, dual nature, or semiconductors. Like yeah, all this. Or if you want thermal physics, I'll take the thermal physics. Thermal physics consists of thermal properties of matter, kinetic theory of gases, and other than that, the thermodynamics. So thermodynamics I have already taken. I think that it's available on our playlist as well. Is it available? Wait, I'll check. Thermodynamic. Thermodynamics formula I have taken, but I haven't taken the theory part and previous year questions. So if you all want, I'll take separate session on thermodynamics. Okay. Now solve this question. In a series LCR, the inductive reactance XL is 10 ohm, the capacitive is 4 ohm, the resistance is provided to you 6 ohms, and you need to find out the power factor. To get the power factor, what we will do is just subtract this XL with XE. So you will get XL with XE, you will get 6, right? 6 and 6 is R. So ultimately, the Z value will become 6 root 2, right? Are you getting my point? We know that Z is equals to under root R square plus XL minus XE. XL minus XC to the whole square. So I told you that you can consider this R, as 6 square plus XL minus XC. So you can consider this as 6 square. So you will get root 2, 6 root 2, right? So you'll get 6 root 2. So 6 root 2 will be your answer. Now you have to find out the power factor. And you know that what is the power factor formula? Cos phi. Cos phi is equals to R by Z. So if you substitute the value of R as 6 and Z as 6 by root 2, it will be cut. It will become 1 by root 2. So your power factor will be 1 by root 2. Right? Shall we move now to the next question? I hope that this question is clear. Now, if we move to the next question, in this question, basically it's asking you a series LCR circuit is designed to resonate at an angular frequency omega is provided to you. The circuit draws 16 watt of power from 120 volt source at resonance. The value of resistance R in the circuit is what? You have to find out. And this question is very, very easy because we know that in case of resonance, the circuit is behaving like a pure resistive circuit. Behave like a pure resistive circuit, right? So if it is behaving like a pure resistive circuit, then you can use a very simple formula that power is equals to V square by R, and you need to find out that what is the value of R here. So it will become V square by P. Voltage, you are providing it as 120 into 120 and the power is 16, right? Just multiply these values. You will get 8, 60, 430, 2, 15, 60, 15, 900. So 900 ohms you are getting. So this is a numerical type question in which you won't be getting any options. You have to solve this question on your own, and then you have to mark the correct answer. I hope that this question is clear to you. Shall we move? Now, let's move to the next question. In this is a question again based on the LCR resonant circuit. The quality factor is given to you. That quality factor is 100 if the inductance is increased by twofold, right? If the inductance is increased by twofold and the resistance is decreased by twofold. Inductance we are increasing by twofold, so and resistance we are decreasing by twofolds. Then the quality factor after this change will be what? You have to find out that what will be the quality factor in this scenario. So you can do one thing. If I need to find out the quality factor, I must know that what is the formula for the quality factor. So quality factor formula is the inductive reactance divided by R. You can substitute this by omega L by R, right? So you can do one thing, that if I need to find out in a case of a resonance, omega, I can substitute this by 1 upon LC and it will become my LC. L I can cut R. So it will become under root L by C 1 by R, right? So this is also a formula for the quality factor. You must know this formula. Now in this scenario, what is happening? Q dash we need to find out. We have 1 by R. The value of this is provided to you. The value of this is 100, right? The quality factor is 100. So in this scenario, what happens here is the resistance is decreased by twofold. That means resistance is R by 2. I can substitute this by 2 by R. The inductance is increased by twofold. Then that means it will become 2L and everything remains same, right? So just you need to multiply it by 2 root 2 into 100. Root 2 value is given to you. It's 1.414. So it's 2 into 1.41 into 100. So Q dash will be 141 into 2, 282. So your answer is 282. Is it clear? Now, this is the last question. So I hope that you enjoyed this class, and please do let me know in the comment at which chapter you want me to take in the next session. We will be taking that in my next class, and please do join our Telegram group to get these notes. Okay. Now that's all what I have to share in this lecture, because I am having some issues with my electricity. That's why I am taking this session using a pen tab. Okay, we'll meet again